My name is Lee Smolin, and I'm a theoretical physicist. I work at Perimeter Institute for Theoretical Physics in Ontario, Canada, and I work on the most fundamental problems about nature. What is time? What is space? What is the universe as a whole? Where did the universe come from? What started it? What was before the Big Bang? In physics, we study systems. We study the air in this room. We study the elementary particles created by a collision at the Large Hadron Collider. We study the solar system, or the galaxy as a system of stars. And these are all parts of the universe as a whole. And it's very important that we treat them as parts of a larger universe, so that, for example, where they are or how much energy they have is defined relative to the rest of the universe that's outside the system. So the very way we describe parts of the universe as related to the rest of the universe is characteristic of the method by which we describe nature in physics. And when we raise our ambition and we come to the question of the universe as a whole, or a question that is about the whole story of the whole universe, like the Big Bang, or how the universe started, or what was before the Big Bang, we're dealing for the first time with the question of how to describe and make a theory of the universe as a whole. And this is a very different kind of theory, a very different kind of questions than the questions we're used to dealing with. And therefore it's important to stop and meditate for a while on what it means to make a theory of the universe or any system as a whole. When we describe a star, we do reference it and describe it with respect to things outside of it. We describe its position relative to the position of an observer who's outside the star. When we describe its motion, we're describing its motion relative to something outside of it, and so on. And that works. That's a legitimate way to do science, except for when we come to the case of the universe as a whole. And then we have to describe a system that contains everything. There is nothing outside the universe. And there therefore is nothing to describe the universe with reference to. And this means we need a very different kind of structure, a very different kind of method, a different kind of theory when we come to study the universe as a whole. Because there's a tradition of thinking deeply, seriously, and critically that goes back centuries, which is what you learn when you study philosophy. Now, if you're not interested in a fundamental question like the nature of time or what is matter or the nature of the universe as a whole, but you just want to apply known laws to known phenomena to understand them better, to understand the behavior of a solid or of a gas or a star or something isolated like that, you can proceed without much knowledge of philosophy. You can proceed pragmatically, we like to say. But if you want to ask the really deep questions, there are these traditions of human beings grappling with the same questions that go back hundreds of years. And not only is it good to know them because it gives you a storehouse of ideas, it allows you to understand your own thinking, because what you discover is that unless you're extraordinarily special and unusual, your thinking is shaped by the philosophical legacy that underlies our civilization.